Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all viewers. My name is Sherry, the moderator for today's session. Welcome to our sixth series of research and innovation webinar, School of Electrical Engineering. This program is streaming live from School of Electrical Engineering, Faculty of Engineering, UTM Johor Bahru's Facebook. Without further ado, I would like to invite Professor Dr. Muhammad Kamal Ibrahim, the Associate Chair of Research and Academic Staff, to give a short opening, as well as introduce our guest speaker, Professor Dr. Zulkurnain Abdul Malek, Director of Institute of High Voltage and High Current, IVAT UTM. Over to you, Prof.
Thank you very much, Puan Sherry, for introducing this event. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera to all viewers. Thank you once again to all viewers that follow this webinar through our FB Live School of Electrical Engineering. My name is Professor Muhammad Kamal Abdul Rahim. I'm the Associate Chair of Research and Academic Staff, School of Electrical Engineering, Universiti Teknologi Malaysia. Our topics today related to lightning safety and emerging dielectrics that will be given by our Director of High Voltage and High Current, Professor Zulkurnain Abdul Malik. Before he gives his presentation, I would like to introduce our speaker today. Professor Zulkurnain received the Bachelor Engineering from Monash University, Melbourne, Australia in 1989, the MSc degree in Electrical and Electromagnetic Engineering with Industrial Applications from the Cardiff University in 1995, and PhD degree in High Voltage Engineering from the same university in 1999. He has been with Universiti Teknologi Malaysia for 31 years and is currently a professor and director at the Institute of High Voltage and High Current, Universiti Teknologi Malaysia. He has published over 150 papers in various technical journals and conference proceedings. He is actively involved in many committees and had delivered several keynote speeches in his areas of expertise such as surge arrestor, intelligent condition monitoring, lightning-related EMC warning system, and lightning protection system. Okay, about the webinar, here we talk about the brief introduction to Institute of High Voltage and High Current and offered services, training, and consultancies are elaborated. Then the talk moves to on the highlight recent research in lightning phenomena and protections, as well as enhanced dielectrics and electrical design. Without further delay, I would like to invite our speaker today, Professor Zulkurnain Malek, Director of Institute of High Voltage and High Current, to give his presentation today. Over to you, Prof. Zulkurnain.
Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to everyone. My name is Zulkurnain Abdul Malik and welcome again to this webinar. Thank you, Prof. Kamal, for the nice introduction. On behalf of IVAT, I would like to thank the School of Electrical Engineering for giving us this opportunity to introduce IVAT and our research work. The title of my talk today is Lightning Safety and Emerging Dielectrics. These are basically the content of my talk today. I will briefly introduce IVAT, followed by lightning topics, dielectrics, electrical discharge, some other topics, and our services offered. Let's start off with a brief video presentation of our institute.
Institute of High Voltage and High Current, or IVAT, was officially established in 1991 as one of many centers of excellence in Universiti Teknologi Malaysia. IVAT's history, however, started since 1970s as a high voltage research and testing laboratory within the Faculty of Electrical Engineering. IVAT has various facilities for carrying out research, calibration, and testing services, consultancy, and hands-on training on high voltage related areas. Research carried out in IVAT are not limited to only electrical and high voltage field, but also involve other related disciplines such as physics, chemistry, and material engineering. IVAT and its researchers have made many collective achievements. Among these are successfully yearly accreditation to MS ISO IEC 17025 of its calibration and test services, more than 3,000 accredited and non-accredited calibration and testing jobs for national and international customers with an income of more than 10 million ringgit, more than 20 million ringgit research grants, over 2,000 publications in many reputable journals and proceedings, more than 100 awards, including invention awards, national and international exhibitions and competitions, 10 patents granted, and more than 150 postgraduate research students graduated, as well as collaboration and international networking with many reputable institutions and industries in many parts of the world. Given the good team of highly committed researchers and support staff, IVAT aims to excel to the highest possible level achievable.
Okay, this is our team at IVAT. We have two accredited labs. So every year we have to do this so-called management review meeting for both labs. We have enough staff for those two labs. This is our organizational chart. As you can see here, there are about 9 support staff and 10 academic staff to carry out our activities. Okay, family values is also important to us, so we make sure we have this activity, so-called Family Day, yearly. What is in common between lightning and dielectrics? Of course, lightning can cause harm to human beings as well as power system. And therefore, since electric power is transported through high voltage lines, which are bare conductors, as you can see here, it's about 22,000 kilometers of overhead line, actually bare conductors exposed to lightning as well. And the underground wire, on the other hand, is insulated, and they are usually for distribution system, MV, which is 11, 22, and 33 kV. So the dielectric can fail due to normal operating voltage, but the high voltage transmission can be exposed to lightning. Okay, you can say we can protect the line using ground cables at the top. As you can see here, at the top there is ground cables that will protect the phase conductor underneath from being struck by lightning. But more often than not, we still have what we call back flashover due to voltage generated at the ground wires that flash through the insulated string here into the phase conductor. So lightning can still pose a threat in terms of line outages to our transmission line. Of course, over voltage in the power cable can also cause damage to insulation. So let's talk about lightning a little bit. Malaysia lies in the near the equator line, and therefore very high lightning activities, around 50 flashes per kilometer per year, and this is due to the thunderstorm activities. And this will result in damage to or loss of life and damage to properties, communication system, power system, sea and aviation, and so on. And as you hear recently, 100 loss of lives happen in India due to lightning. So there is a need for the masses or the people to be educated and well informed about lightning. So we are still need an efficient, for example, warning system or locating system, or we actually need to study more about lightning to understand its behavior. As you know, lightning actually comes from water evaporated into the cloud, and the supercooled water droplet will precipitate due to a dust, for example. And the supercooled water will freeze at the outer layer there due to precipitation, and the H plus will have the outer layer will have a 0 degrees Celsius, whereas the inner part, liquid part, is actually still at very cold temperature. And this temperature gradient will force the migration of water ions, H plus at the outer and OH minus at the inner. And when the inner part freeze, it will expand and therefore will cause a splinter of the outer layers ice into small positive particle splinters. And this updraft will bring the splinters upward, and the negative rain, liquid rain, will be going downward in the cloud. And therefore, finally, you have what we call a thunder or electrification of cloud, mainly positive charge at the top of the cloud and negative charge at the bottom. And more importantly, due to this cloud, negative charge at the bottom, it will correspondingly induce a very strong positive charge on the ground underneath. So basically, we have pockets of charges in the cloud, and the insulation between them are just air, and the insulation between cloud and ground is also air. And when the voltage is critical enough, or rather the field is critical enough, you have what we call electrical discharge. Some of them are intra-cloud, inter-cloud, cloud to sky or sprite, and of course the most important point is actually from the cloud to ground discharge. So when the leader connected from the ground object, a very large current will flow, as you can see here. Basically, the positive charge will flow upward to discharge the negative cloud. And doing this will cause a very large current to flow up to 200 kA maximum. And this large current will cause a very high voltage at the point of entrance in the cloud, in the ground. And this will cause a very high touch and step potential, which is dangerous. And also the high current flow can cause induced voltage or spikes inside nearby loops. And if the house, for example here, is made of flammable material, the strike on the house itself can cause fire, for example, and therefore property damage. So we intentionally put air terminals at the top with a down conductor and a grounding electrode inside, so that the current can be safely discharged into the ground. So a good LPS will have all the component of a good air terminals, down conductor, as well as a grounding electrode. So one of the useful tools for efficient lightning protection system, as for example, just now, if I can go back, do we need lightning protection system, and how to help to get a better lightning protection system? One of the tools is actually using lightning locating system, and this will make our lightning protection system more efficient. And basically, a lightning locating system is to locate a cloud to ground discharge, coordinate, and then plot them onto the map. So how to locate the CG strike? A strike like this, from the earth, from the cloud to the upward leader there, will cause electromagnetic field to be propagated around the earth for thousands of miles or kilometers. And we can measure the location of the discharge or the emitting EMF using basically two techniques, a popular one, time difference of arrival and magnetic direction of finding. The two parameters that are important in the measurements are the accuracy and efficiency. In Malaysia, or rather in Peninsular Malaysia, we have a TMB system with about 5 sensor locations there throughout the peninsula. And over the years, they can actually map the locations and density of lightning strike around peninsula. So what we do here in Malaysia is, in UTM, is actually to try to make our own lightning locating system for local area. So what we do, we have 3 sensors like this, and as you know, for time difference of arrival, using only 3 sensors will cause 2 solution of hyperbolas. And this 2 solution is with the fall and correct position of the stroke point. Therefore, we use some kind of artificial intelligence or training data to actually locate or determine the correct stroke position, and we successfully do this for about 20 kilometer radius of lightning strokes within Skudai. And as you can see here, the 3 locations are all in UTM Skudai. So we save 1 station there, cost. But now we are moving into another technique which is called interferometry antenna system. Basically, when lightning signal arrive at the antenna, the different phases between the signals can give us information regarding the elevation angle beta and azimuth angle alpha. And by doing this, we can actually locate the source of discharge, and we can plot them in 3D as you can see here. And the movement of the discharge can also be traced, and this is even better because then we can actually detect the discharges not only cloud to ground, but also discharges in the cloud prior to the cloud to ground discharge. So in the current project, we may also incorporate the weather to actually give us better indication of lightning, as well as field meal on the ground, apart from the interferometry data. So what are the parameters that are important inside the thunderstorm warning system? Basically, we want warning. For example, is we are living in a target area. We want to have some time so that we can take cover, at least 20 minutes. And after the thunder is clear, we want to have as much as possible time, or sorry, as fast as possible to be cleared or clearance, so that we can move to our work. So here, what the two parameters is actually probability of detection. If we can make failure to 1-0, then we have 100% POD, and if we have a false alarm of 0, we also have 0 false alarm ratio. So what we do is actually we try to improve this timing. And in Europe, they have already done a POD or effective alarm with 20 minutes, at least 20 minutes in advance, are actually quite high, but not 100%. So we try to do this for Malaysian case. We haven't got data for that, but this can be the data that we have from TMB, lightning location, can be used to train and therefore obtain all this information. So this is part of our work. So in the end, what we have is actually a system maybe in southern Johor, and we can use this to give a warning to many people, including industries, for example, aviation industries. Okay, a thunderstorm warning system can help minimize losses and damage since it can take precaution. But do we actually need an LPS or lightning protection system? For a given installation, our house, for example, whether we need or not, we have to do what we call risk analysis. So all this is covered in IEC 62305, whereby we 62305, 63025, whereby we can actually design the lightning protection system according to the standard. And whether we need or not, it depends on the risk analysis, and what class of protection we need also depend on the risk analysis that we carried out. So for the power system, we have what we call lightning protection system for the expensive equipment, for example, the transformers at the substation. So the surges can still go into the station through the lines, and therefore we need to put arresters near the transformers, or in the case of transmission line, we need line arresters to reduce flashover rate or to reduce bad flashover problems. And the arrestor need to be constantly condition monitored so that they are working perfectly throughout its years. If they fail, then you are exposing your transformer to damage as well. So we in IVAT have developed what we call Bluetooth and web-based measuring system, so that we do not have to do record manually and then go back to the station and key in the system. So we do this using a bit of IoT, and we even use a thermal camera instead of a scanner, sorry, a clamp meter, which to detect leakage current. By the way, the leakage current flowing at the bottom of the arrestor can actually indicate the aging condition of the surge arrestor. So since the more the leakage current, the hotter the body of the arrestor, we can use thermal scanners to detect the aging condition of the arresters. And of course, we need to do some digital processing because of the image, and some kind of artificial intelligence to correlate between the image that we scan on the surface of the arrestor and its expected leakage current internally. So one of the component of LPS which is important is the soil itself, where we bury the ground electrode. If the soil is of high resistivity, then we may have a very high ground potential rise, because the current that flows into it will see a very high resistance, and therefore I times R will be very large. So the location of our, for example, solar farm is important to be to know the soil property so that we can minimize the ground potential rise in the event of lightning. So this study is also done in our institute, and this is a typical ground potential rise plot. The soil itself can also behave differently under different conditions. So we need to model this. We need to model the soil ionization, for example, where it behaves differently under a very different current rate of rise, or very high current rate of rise. So this is also part of our work, and all this work are being published in the journal. So apart from the lightning protection and lightning location system, we want to see what are the other effects. And this is our downward leader again. Because of the long distance, we are actually transferring the air.
It has an extraordinary effect on objects on the ground. They respond to the strong electric field by growing positive streamers. These reach up anywhere between 3 and a few hundred feet above the ground, as seen in these rare photographs. Finally,
so what happens is, when the leaders start coming down, it brings with a very large electric field, which can actually induce upward leaders from the grounded objects. And this doesn't spare the so-called vent stack at the chemical industry. And these are cold vent stack where waste gas are coming out from here. And more often than not, the waste gas are flammable, and they are not supposed to be igniting fire. And therefore, if fire catches because of some sparking at the edges of the vent stack, at the moment we release the gas, then this will be a cause for concern to the owner of the unit. Okay, so the proof of it, they have seen sparks during thunderstorm as well as fire when there is a nearby lightning strike. So our theory is that even though it's quite far away, the vent stack can also have an upward leader discharge at the edges, and this upward leader has a good or upward streamer has enough energy to actually ignite flammable gas. So what we do, we have simulated a very large current flow and a very large voltage here, massive electric field, and our vent stack is quite 100 meters away, can actually have a voltage, or rather electric field induced at the edges, typical of a breakdown voltage, which is 30 kV per centimeter. So this is proven that the edges can produce corona due to the nearby leader. So the next thing we do is actually we conduct the experiment. So because we don't have the cloud, we use a DC electrode to induce the corona on the vent stack model here, and we use butane gas as the flammable gas. And the important thing is that can the leader that is or the upward streamer that is produced at the edge of the vent stack it start to ignite the fire, and we have proven that is true. And this is one of the video that we captured. Okay, this is DC, that's why you have multiple flash over there. Okay, we also do some studies on what happens if the lightning strike going to the ground, if you have a gas pipeline nearby, what happens to the coating? And also if you have a short circuit due to fault, for example, what happened to the, again, to the coating on the pipeline. So we do studies and publish these results. Another thing that we do is, regarding lightning is the characteristic of the lightning itself. And we can use certain tools to actually characterize lightning better. The first thing we do is actually to measure the signal, maybe using parallel plate antenna here, and a good capturing system. And the antenna itself have many circuits that can cater for many ranges of frequencies. And we cover Southern Johor over the period of about 3 years. We have about 868 data. And from this data, we can get lots and lots of signals. And typical signal shown is actually, the first one is actually fast electric field. As you can see, the primary breakdown pulse in the first one, and then return stroke 1, return stroke 2, return stroke 3, 4, 5, and so on. And correspondingly, for the slow field buffer circuit, we can, for the same signal and slow field measurement, we can see the signal there and the corresponding 3 MHz band, 30 MHz band, and the derivative signal. So all this can be further analyzed temporally in the time domain, and measure all the parameters that can be used to compare with other geographical regions, for example, in temperate regions. Tools such as wavelength analysis can also be used to investigate or actually identify what type of discharge it is. And not only identify, we can also predict what is the next pass coming after the first pass, for example, here. And you can actually plot this so-called power spectrum, frequency versus time in microsecond here. And based on the shape of the plots, you can identify whether it is positive, negative, and so on. Cloud. We also want to study the effect of sea, or the propagation, or the lightning on the sea, or the propagation over the sea. So we install antennas also on top of the mall here at Kuala Perlis, and also in Cebu. And here we have even a high-speed camera to actually capture lightning in real time. There, with the high speed, you can actually capture the activity of lightning. So this will help us to actually finally have a better lightning protection system. So in summary, we have described lightning activities that we do here. Basically, lightning locating system, thunderstorm warning system, lightning protection system, lightning EMC, and lightning characterization. Now, the next thing I want to discuss is regarding emerging dielectrics. And this is the second part of my talk, or the second part of the title. And high voltage insulation such as polyethylene, polypropylene need to be continuously improved in its property. And the main property could be like dielectric strength, aging resistance, PD resistance, tracking resistance. All this can actually produce new material that can make the dielectric last longer and make it thinner in terms of strength. You use less material for the same strength. So one of the way to do is actually to put fillers, basically nano fillers, into the base matrix, because the base matrix has many empty spaces that when filled with nano fillers can make property change. So what is a nano dielectric? Nano dielectric is basically mainly polymers in which nanometer sized fillers, for example nanosilica, supposedly to homogeneous disperse inside its matrix, but the percentage of the nanofillers is very low, about 5%. Okay. The most important part is actually the interaction zone between the nanofillers surface and the matrix. And the zone itself, what we call, corresponds to an intermediate region where material properties are representative of neither polymer nor the nanofiller. So one of the main issues in this nano dielectric is agglomeration. So by treating the fillers better, we may help to make the homogeneity of the filler better, but at the same time, the filler itself need to be treated actually, firstly, because it may contain, for example, water, and if we do not treat them, for example, and the treatment can be done using either thermal, chemical, or even plasma rays. And as you can see here, for example, the 5% of nanosilica in polyethylene will have, if you treat the nanosilica before making the nano dielectric with level 8 of the chemical treatment here, we have the best performance of breakdown strength of the resultant nano dielectrics. Here we can see the base matrix itself is polymer. It doesn't absorb water, but once you put the nanofillers, it's actually absorb water, and therefore we need to be careful what filler we put so that we maintain the property of the dielectrics, and not, as you know, water it's not very good for insulation. And another treatment, we can actually heat up the nanofiller first, or calcination, and therefore throw out the water. And as you can see, calcination at 900 degrees can actually result in a very improved breakdown strength of the nanofiller itself. So the temperature of calcination is also important. During MCO, the student may not be able to go to the lab, but they can still do modeling work. So here you can see nano dielectrics, even though at very small size, can also be modeled in terms of interaction with the surface base matrix. And this is an example of polypropylene-based nano dielectrics. I think these are the white things here are the nanofillers. And as you can see here, the water, if you are not careful, the nano dielectric can absorb water and therefore make the property worse. And also one of the other study is actually aging by temperature, and see how the performance of the nano dielectric perform. As you can see here, with a certain correct percentage of fillers, you can have a better aging characteristic of the nano dielectric. Apart from solid, we can also treat a fluid, for example, transformer oil, by adding again fillers, nanofillers, and you can also treat these nanofillers using, for example, plasma radiation. So apart from having new dielectrics, we want to also maintain the dielectric strength, or actually improve dielectric strength, by using intelligent diagnostic and condition monitoring of the dielectrics or high voltage equipment. So this is because even at normal operating voltage, the dielectric are continuously stressed, and as you know, partial discharge occur even at operating voltage. So it is very important for us to detect any problem with insulation in advance. So one of the technique that we can use, and this is non-destructive technique, is called polarization and depolarization current. And we developed this equipment in our lab. Basically, you have an insulation here, whereby we can actually charge it using a voltage, and then because of the dielectric, it start to polarize, and therefore a certain current will flow. And we measure this current, and after a certain time, we disconnect the voltage, and it polarizes again, and we measure this current. And the response can indicate the condition of the dielectric. For example, in a transformer, you can see here the polarization current. If it behaves in a certain way, for example here, it may indicate aging of the oil, and here content of water inside the oil. Another diagnostic that we can do is actually to detect the leakage current on the string insulators. These are the overhead transmission line where we hang our phase conductors. And to detect PD may be difficult, but it is possible to detect leakage current that flow inside the insulators. So therefore, if we can do this technique, it is very useful to actually pre-diagnose our insulators before it fails, and therefore cause supply interruption, for example. So we developed this tester up in the lab and measure leakage current and correlate them with the trapped charge. Another important characteristic which actually we look into the new dielectric is high tracking resistance. This is especially true if you want to minimize surface discharges and therefore damage to the insulation. So basically, we have two electrodes here. We put some liquid as well, and therefore when the liquid dries, spark will start to appear. And this spark will cause, if the material is very high tracking resistant, it will prevent any carbonization, meaning to say we can develop material that actually resistant to tracking. Apart from solid, we also have what called gaseous insulation. SF6 is used in many GIS, gas insulated switchgears. We have 132 kV station with GIS switchgear in our campus here, and uh, one condition monitoring that we need to do is continuous PD monitoring. And we can put sensors, but also we can actually do a very simple test by taking or extracting byproduct gases. Sample the gas from the switchgear, send to the lab and measure the byproducts. And we do this in the lab and we simulate the defects that cause the partial discharge to occur inside the gas chamber. And the type of byproduct that we detect dependent on the defects that we introduce. For example, SOF2, SO2F2 appears always in protrusion defects. So we can use this to diagnose the defect inside the chamber or inside the GIS by just looking at the byproduct gases. So in the lab, we have two chambers carried out in parallel and energized at about 50 kV and over 5 days, and we take sample every 1 day. And we can introduce protrusion here, maybe copper needle at the electrode, as well as floating particles needle in the chamber itself. And then this will, when we energize the chamber, it will create discharges. So we do two chambers, and then we confirm the discharge, or sorry, the byproduct is confirmed not only one, but also in the other chamber. And as you can see here, we can also use some kind of intelligence to actually help us to identify, based on the gas parts per million content, what is the defect inside the chamber. And apparently random forensics is better than SBM. As you can see, only this one is wrongly classified as all free conducting. Here the protrusion is wrong classified, one is classified as fixed non-conducting. So but basically it's about 70-80% true or accurate. So in the end, we would like to have something like a GUI interface whereby the operator can just put parts per million byproduct gases here, and then it will predict what is the defects and whether it's mild or a very severe discharge occurring. So apart from gas, we also have various high voltage equipment, for example, motor and transformer here in our campus, all to be detected using special equipment here, and also cast resisting transformers. You can also detect the P in advance before total breakdown occurs. So for cable system also, we can do some kind of PD monitoring. And the beauty of this is that a system that we have can actually detect the location of discharge around, for example, 4-kilometer cable, and we can know the type of, not only the location, but also the type of discharge based on the phase resolve signal, as you can see here. So this is good, so that if it's at joint, then it's not XLPE, that is maybe on PD. And also for the motor, of course, we have tangent delta or power factor, as well as PD offline test here that can be used to monitor the motor condition. Again, we can also model the partial discharge using, a cavity here inside the again machine here. You can actually simulate this in a finite element, but we use MATLAB simulating to actually simulate the behavior of the discharge. So in short, I can summarize that we are trying to improve the dielectric by using, for example, Nano Dielectrics. But what we are basically doing is actually to increase the breakdown strength of materials that we use for insulation. We want to increase the properties, including PD and cracking resistance. But at the same time, we also want to improve the condition monitoring techniques of those dielectrics. Electrical discharge is the next topic I want to discuss quickly. And as we know, we do not want the electrical discharge to occur in our insulation. But we can also use electrical discharge for our benefit. For example, to clean our water, to treat our fruits, to treat our mushroom substrate, or to treat our nanofillers. So what we do, what we have is plasma is actually ionized gas, and they are useful in many applications, including biomedical application, as you can see here. And also for lighting. So this is the property when the ionized gas, it produces certain frequency that emit lights, and you can also use it for plasma TV, make it faster and clearer TV for you. And if you put oxygen through a discharging electrode, you will have ionized oxygen, which at the end you can have what we call ozone or O3. You can also use the discharge plasma ray to clean the air, as well as to treat the surface of material like we have discussed before. So this is one application of the plasma, actually for carbon nanotube applications, as well as ozone can be used. As you can see here, this all discharge oxygen going into the discharge chamber through this ozone, and the ozone can be used because of the reactive property to clean water. Okay. Also, we can use it to clean or to clean our mushroom substrate. Traditionally, people use hot water or steam water before this, but now we can use ozone with more efficient and faster process. Apart from discharges, we also have what we call electric field generated between electrodes. And this electric field is known to be able to treat or to kill bacteria. And we can use this electric field purposely if we can put a chamber between electrode and where electric field present, and the juice can be treated, if you like. And this depend on the flow rate, the field, the flow, the laminar flow, and so on. So this is some of the work is carried out here to design a chamber that the juice can flow, but at the same time give a maximum output rate, if you like. And the electrode is built inside here, but what is important is the field distribution experienced by the juice. Also, the as you can see here, basically the plasma treatment, plasma can be generated by two electrodes breaking down, as you can see here, but with we call it dielectric barrier in between. And this will give a kind of glow discharge or glow filamentary discharge, as you can see here, depending on what you want. And you can control all this. And this is one example of the system that we use to generate such plasma and treat our nanoparticles there. So again, this is, as you can see here, this is cold, not high temperature plasma, because under high voltage, you can have gas ionization as well. And as you can see here, the nanoparticle surface, when treated with plasma, behave better inside the polymer. One last topic is on the okay, this is again, I'm sorry, this is again using pulse electric. So here to treat fruit or to for food preservation, basically you need to generate a right voltage, a right field with a certain wave shape to actually treat the food successfully. Electric field can be used for to treat food, but also can be harmful if you, for example, stay under transmission line 24/7. And we are often doing this measurement under various under high voltage transmission line, especially at the housing estate, as requested by the owners or the sellers. And we know that the exposure to beyond the safe limit can be harmful. Therefore, we do this field measurement as part of our activities as well. And another one is actually EMI, or electromagnetic interference. For example, from so we have a high-speed rail, produce this arcing at so-called pantograph arcing. And how does this arcing affect our, for example, electronic system or our phone, for example? So this is to do with EMI. So this is part of the study related with the high-speed rail. So finally, I would like to recap our services in IVAT. Basically, we do calibration, testing of high voltage equipment, training, as well as consultancy work. And of course, mainly high voltage meters and high current, as well as high voltage equipment we test in the lab. And these are the scope of our calibration, as you can see here, and the calibrated scope, accredited scope for the testing, but we do all other non-accredited tests. Basically, what I've discussed so far, the topics, we can do consultancy on it, as well as training on it. So feel free to contact us anytime to discuss further on this, any future collaboration. We also do training in any of those topics, including grounding here for Petronas engineers, and partial discharge, for example. Dr. Hafizi here is doing training on partial discharge to many people. And please feel free to visit our website here, and you can see our yearly newsletter there and all other information, including the form if you want to do calibration at our lab. So finally, I would like to announce that next year, inshallah, we will be hosting, Malaysia will be hosting a flagship I2P flagship conference on the properties and application of dielectric materials. So please send abstract. Thank you very much.
Okay, thank you very much, Prof. Zulkurnain. Again, I would like to take this opportunity to thank Prof. Zulkurnain for sharing a very informative on lightning and imaging dielectrics. Now, I would like to open for any Q&A to all the viewers. You can post your questions at the comment of your Facebook. Okay, so if there is any questions, you can post at the comment of your Facebook. Okay, so before we have questions, so maybe I can ask Prof. Zul about one question here. What do we do to protect our lives and properties from lightning threat? Maybe
Okay.
Prof. Zul has answer on that.
Thank you, Prof. Kamal. Basically, I've touched a little bit just now. We have 4 parts of standard IC 62305, whereby we can actually assess whether we need lightning protection, at least for our structures or not. Apart from that, for personal protection, we need to know what we do in the event of lightning. To have a warning system or portable warning system or personal warning system is also good, so that one can take cover in the event of impending danger of lightning coming nearby.
Okay, thank you. Okay, maybe another question. What are the new ideas in enhancing the dielectrics? So you talk about the dielectrics here. So is there any new ideas from the dielectrics research?
Thank you, Prof. Kamal. For the high voltage application, one important property of the dielectric is permittivity. And there's a trend now to actually design new material, dielectric material, with variation in permittivity. So we need to actually design a material with a so-called non-linear permittivity across the profile of the material. And this is very useful in certain application. For example, if you want electric field to be uniformly distributed, for example, or to be manipulated, for example, so you can do this by changing the property of the dielectric itself. And of course, the dielectric is under the stress of electric field. So apart from that, of course, nano dielectrics, I can see many futures in improving nano dielectrics, but the challenge is actually to improve in all aspects of the property, including mechanical property and physical properties of the dielectrics. You don't want to have a very high dielectric strength, but at the same time, very weak or very fragile material. You end up with this. So there's a lot of work to do, still to do in this, but these are the emerging new dielectrics in the future.
Okay, all right, thank you. So maybe last question. Why do we have many types of lightning air terminals? Maybe Prof. Zul can elaborate it more.
Okay, this is quite a sensitive topic. as you can see just now, air terminal is supposed to intercept lightning and then safely discharge them to ground through down conductor. There are many claims that say you can actually make the air terminal intercept lightning current, but at the same time reduce the current to a very low value. We call it SLE, or semiconductor lightning eliminator. So in this way, you minimize the magnetic field associated with a large current flow on the down conductor, and therefore you have a safe you are safe from this high current flow. But these are all non-conventional. There are also types of air terminal which claims that you can actually suppress the upward leader formation. So meaning to say you try not to intercept the lightning, or you try to push away the lightning, because this is based on the striking distance. But some other air terminal claim to be actively putting an upward streamer to attract lightning better. So all this claim results in many products of air terminal. You can see all kinds of air terminals with all kinds of shapes, and some of them are called passive, active, upward leader suppressor, downward leader suppressor, and so on. But the standard only specify one, which is actually the normal Franklin rod that can actually safely intercept lightning and then discharge to the ground.
Okay, thank you. But I think for the lightning, can you control that? Can we control the lightning?
Yes, a good question. There are people trying to not only control, but they try to intercept the energy. So to control is very difficult, because to control means you have to control the cloud. But just now I was saying to repair lightning, meaning to say you make your air terminal. Your air terminal doesn't produce upward streamers. So this is one of the claim. But to control the leader coming down is not possible, because the cloud moves as it likes, where it moves based on the wind, and when it comes down only about 100 meters away, it will decide where to strike. So it is too late now to control. The only way to control is to move away the cloud if you can.
Okay, there is one question for Senjata Apo. I don't know who is it. How a dielectric experience electrical breakdown, and what is the main factor that contribute to it?
Say again, experience?
How a dielectric experience electrical breakdown, and what is the main factor that contribute to it? I think he want to ask about the dielectric.
Okay, the dielectric actually have a very strong internal breakdown strength. So it is very difficult to actually break down the insulation through the solid dielectrics, if you are referring to solid dielectrics. So most of the breakdown is due to the surface discharge or the partial discharge inside. So basically we have a kilovolt per centimeter dielectric strength. So when the stress between the two electrodes or across the dielectric exceed this breakdown strength, being solid, it is very difficult for the particle to ionize, unlike gas and maybe liquid, whereby a very strong electric can easily ionize the gas and therefore become an agent for conduction. So for dielectric, if you're referring to solid, it is a very tough, and usually they fail due to other factors, for example, internal voids and tracking, treeing, as well as surface discharges. But otherwise, they have internal breakdown strength. If you want to do, you just increase the voltage until it breaks down. So basically, ionization occurs, but of course, because of being solid, the bonding is very strong. To make it break, you need a very large voltage.
Okay, all right, thank you. With that, thank you very much again to Prof. Zul. Okay, once again,
thank you.
To all viewers that watch this FB Live from School of Electrical Engineering, Faculty Engineering, Universiti Teknologi Malaysia. Okay, thank you very much. Now I would like to pass over to Puan Sherry for the closing of this webinar series and highlight our next webinar series for the Research and Innovation School of Electrical Engineering, Faculty of Engineering, University Teknologi. Over to you, Puan Sherry.
Thank you, Prof. Kamal. And thank you also to our guest speaker, Professor Dr. Zulkurnain Abdul Malek, for the interesting topic just now. Thank you, Prof. All right, viewers, we are at the end of our session today. Thank you all for taking out time to watch this live telecast. And for those who missed this live session, can watch the video again in our Facebook. Don't forget to like, comment, and share our Facebook and videos to your colleagues and friends. And please also don't forget to join us next week, 28th of July, 2:30 p.m. for the next series of webinar with our guest speaker, Associate Professor IR, Dr. Muhammad Rizwan Ahmad, the head of Micro Nano Systems Engineering Research Group, on the topic Towards a True Non-Invasive Early Disease Diagnosis. All right, viewers, as usual, I will end this session with a quote. One small positive thought in the morning can change your whole day. So dolls, keep on dreaming. See you all next week. Stay safe, keep your distance, and stay tuned. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.